Quick question. I was studying the questions here for the test, and I went through the videos and I couldn't find where can I find on the CM or BGA about labor hours, how to calculate labor hours. There's a Mhm.
Yeah, that would be module 5. Actually, sorry, module 6.
Okay.
But I can go over that right now if you want.
Let's see. And we types of coverage benefits. Okay.
Was it a particular question in the on the
Yeah,
exam?
that is basically saying ABC Construction was estimating the cost of doing a new remodeling job. If the total estimated of the new job is 1,560 hours, 1,560 labor hours, based on the actual to standard ratio of 1.3 to 1, what are the standard hours of the job should take?
Gotcha.
And
All
then
right,
I was trying to find something on like a table or like how to calculate this. And I couldn't find it.
No worries. Go to BGA. Yeah, go to page 190. I think that's where it's going to be. Labor performance standards. Yeah.
Yeah, and then yeah, I see this table.
Yeah. Well, so you think of I don't know. Can you see my screen here? The writing.
Yeah.
Okay. Let me spotlight myself so I can be a friend. Okay. So whenever this is like actual to standard, so this is the actual number of hours that something takes you, and this is the standard that you would get off some sort of like estimating book, like this, like the industry standard, in a standard number of hours, right? So if it, let's say project actually takes you 100 hours, the standard is 100 hours, your performance ratio is a 1. So that means it took you the actual amount of hours that it should have, right? If your standard is actual hours is 100 and your standard is 300, right? Then you're 1/3. You're good. That's great.
Right.
If your actual's 1 and your standard's 50, then now you're at a 2, right? So this job's taking you twice as long as it should. So what you have to do is if they give you, I think what this is, a 1.3, that's your ratio. Okay. So if your ratio is 1.3 and then it gave you the actual standard of hours at 1,560, was that right?
Yes.
Okay, 1,560 times some number, right? Divided by one number equals 1.3.
Right.
Okay, so what you can do at that point is, that my actual numbers is going to be, so I had to figure out, okay, what number here is going to give me 1.3.
Yeah, so that 1,560 divided by 1.3.
Yeah.
That gave me 1,200.
Right.
That's how many hours this should take.
Exactly. That's the standard.
Man, oh man.
Yeah.
Yeah, I got it now. Because when I saw the table, it was like type of work, and it didn't say anything in the question about type of work. So I just got confused.
Yeah, and I like to draw it out kind of like this, like, actual to standard, that's my formula, right?
Right.
And then I just start plugging in numbers. And if they give me the actual to standard number, right, I just plug that in and this, and it just, okay, what do I need here to get to that?
Wow. Okay, good. Thank you.
Yeah, you're welcome.
I have a question.
Yeah, go for it.
Okay, from the manual, the study manual, the module 10, there's a lot of problems, and I've been trying all of them, and they usually take me more than 4.5 minutes to solve any single one. So which ones do you think we focus on?
Yeah, so I would say the ones that I've seen that have been on the exam, so they've test it can be either CA, the contract administration, or project management, and definitely the question on acres, calculating number of acres. All right, now that could be acres of a sodded area, acres of a certain section of a I don't know, of the lot, but number of acres, that's one. Also, they've been asking volume of concrete. Now, they've asked volume of concrete. I've seen it in the staircase, like a concrete steps. I've also seen this, I mean, run out of ink here. Where's my other one? No, this one I have to do. The other one I've seen is in volume would be for a pile cap. Right, or even a footing or a column or something like that. So you could have, like, for instance, let's say you have a staircase. I'm going to make this very straightforward here. Can you see that okay?
Yeah.
Okay. So say you have a staircase here, and I'm going to make the math easy. Let's say it's 1 foot risers. Right. And let's say it's 1 foot deep. All right. So just making this simple. So, and we want to calculate, and then the staircase itself, right, is going to be, let's say the staircase itself is, I don't know, 20 feet, right, deep. So how much concrete do we need for this? So it's an odd, kind of an odd, odd shape, right? This is not a standard shape that we can calculate. So what we do is we just divide it in, we just separate it into standard shapes. So we got a square and 2 rectangles. So section 1, 2, and 3 here. And what I try to do is just calculate the face area, like a 2-dimensional space here, and then just multiply that times the 3rd dimension, which is my width of my staircase. To find the volume. So, because we know that volume is length times width times height or depth or whatever, 3 dimensions. So area 1 is 1 foot by 1 foot. So we got 1 square foot. Area 2 is 2 feet, right? 1 foot, 2 feet times 1. So we got 2 square feet. And area 3 is 3 by 1. So we got 3 square feet. So 3, 4, 5, 6. So you got a total of 6 square feet times 20 feet. That's our lineal footage, right? So we got 120. Now we have a cubic measurement. Is that right? Yeah, 120 cubic feet. And then to convert into cubic yards, you divide by 27. Now to give you a cubic yard number, which, what is that, 3, 4-ish, between 3 and 4?
It's
So
4.4.
4.4?
Yeah.
So it'd be 4.4 cubic yards. That's how much concrete you need here. So if you're doing an estimating project, that's how you would estimate how much concrete you need. So that's kind of the staircase concept. Now the numbers may be different, but the concept is the same. So you take the face area and then you find out whatever that is, the square footage of that, and that's it, and divided by the length. As far as the acres go, you know, the main, kind of the trickiest part is they could give you a lot that kind of looks like this shape, right? Which is basically just a trapezoid. And so, you know, how do you find the area of this? Let's say this is 100 feet. Let's say this is 50 feet, right? And we know that the depth of this lot is, let's call it, I don't know, 75 feet. So to find the area of this shape, you basically need to, again, kind of turn it into a regular shape. You can do that mathematically by taking let's call this A, let's call this B, right? So you can take A plus B, and divide that by 2. That's the average of these distances. Multiply that times the depth. And that's actually how you find the area of a trapezoid. So in this case, it's going to be 150 divided by 2 times 75. So that's 75 times 75, whatever that is. I don't have my calculator handy.
Oh, that's 75 times 75 is 5625.
5625, perfect. And then to convert into, now if they want the number in acres, 1 acre Yeah, there we go. So 1 acre equals 711, right, in a donut, so 45, 43, 560. I think that's right. So if we want to convert that to acres, then it's going to be 5625 divided by 1 acre, 43,560. That'll give us the number of acres. For that, so that's kind of this question. The volume, that's the staircase. If you go to sheet, I think it's on the module 10 plan set, if you go to sheet 9, maybe there's the pile cap schedule. See if I can pull it up on my Do you have the construction calculator?
Oh, yeah.
Do you have it? Okay. So the construction calculator does all these conversions for you. It converts to acres. Do you want me to show you how to do it? Or are you good with the construction calculator?
Oh, yeah. I was looking for that function on the calculator, but I couldn't find it.
Oh, no worries. Let me show you real quick. I can share that. Hold on. Okay, bear with me. Let me pull that up. All right, so yeah, some of the basic functionality here. You can see the calculator, right?
Yep.
All right, so for acres is right above the number 2. So I think we have what 5625. So 5625 square feet.
Mhm.
Just push convert to. And it does the conversion for you. And if you want to know how much 1 acre, how many square feet, you can do 1 acre and then feet. You don't really need that if you have the calculator. The volume measurements, it does it. So let's say I think we had 120 cubic feet in our initial example for the step. So 120 feet cubic feet. If you just click yards, it'll convert it automatically, or to inches. You just toggle back and forth.
Okay, from feet to acres, how do you do? Because I'm not getting it.
Yeah, so well, we have 5625, so put 5625.
Right.
Now you got to put feet. You got to click feet twice, so it
Oh,
shows
feet
square
twice.
feet.
Okay.
Yeah.
That's what it is.
Yeah, and if you click feet again, it'll do cubic feet. So you just got to tell it what units you're using.
And then convert to.
Yep, convert to, and that should work.
All right, thank you.
Yeah, you're welcome. And then a couple other quick things on this that you may need is the area of a circle. So, the diameter. Usually they'll give you the radius on the exam on the plans. So the radius is, you can use the radius. Let's say the radius is 90 feet. You have 90 feet, right? Your radius. You can do it the longer way and just put 90, convert, and above the arc says radius, and then click circle. And then it just converts it to diameter, which is twice the radius. And then you can click circle again and it gives you the area.
Oh, wow.
Click circle again, it gives you the circumference. But I just double the radius and save that step. So if I know the radius is 90, I'm just going to put 180 feet, circle.
Okay.
Okay. And that's another thing. So circumference is more like perimeter, right? It might tell you like curbing, how much curb do you need in a certain area for a parking lot, and they'll give you it's a circular shape, or it might be half a circle. So if it's half a circle, then you got to just divide this number by 2 to get that, half that number. What else on this? There's other functionality here, board feet. They might ask you as an example. So board feet is just a unit of measure. It's a volume measurement. It's like cubic yards or cubic feet of steel. It's standard of basically how to buy like mass amounts of lumber, instead of dividing it up like, I need this many 2x4s, this many 2x6s, and this many 2x8s. on really big projects, they'll just sell you the lumber in a volume, like you're buying X amount of volume of lumber. They don't call it volume, they call it board feet. And board feet is basically one foot of a 1x6 piece of lumber. The formula for board feet to calculate it, I mean, we can do it on the calculator, but it's basically going to be equals your dimension of your lumber. So a 2x4, whatever, times, plus the lineal foot, how long it is, and all that divided by 12. That's the conversion if you're going to do it manually, but the calculator does it for you. So let's do that real quick. So let's say I have a wall, and that wall is I don't know, 100 feet long. And I have stud spacing at, I'm just going to make the math easy, at 1 foot, 12-inch stud spacing. Then in the wall's 10 feet high. As a matter of fact, let me just draw this out. So we've got a wall, studs, right? The wall is 100 feet. It's 10 feet tall. We've got a single top plate and we got a single bottom plate. And we got spacing 12 inches. So if I were to do this manually to calculate board feet, and let's say we're going to do 2x4, just as an example. Okay. So first thing I need to do is I need to calculate my total lineal footage, right? I need to figure out how much lineal foot of lumber I have. So in this case, I know I have 100 feet of wall. So to find my number of studs, I need to take my total lineal footage divided by my spacing, and I got to add 1 because the first stud here starts at 0. So, and again, the calculator does this as well. So if I have 100 feet of wall spaced at 100, right? So I have 100 lineal feet divided by spacing of 1 foot, then I'm going to add plus 1, right? I have 101 studs, right? So if I have 101 studs, I know this 10 feet, 101 times 10 feet equals 1010 lineal feet. So that kind of did the hardest part already. I know I have a 1010 lineal feet of stud, and then I got a top plate of 100. I got a bottom plate of 100. So I got 1210 lineal feet. Okay. And then I'm going to take 2x4 by, so this is supposed to be a multiply, by 1210 divided by 12. Let's do it on a calculator. So it's 2x4 by 1210 equals divided by 12. We have 806, let's call it 807 board feet. That's doing it manually, right? But if we know, we can actually use board feet. There's a feature here above 8. The way we enter board feet on the calculator is you enter the dimensions in inches because it's like you're doing a volume calculation. So you have a 2-inch by 4-inch by 1210 feet equals, now this is giving you this thing in cubic yards, which is that's not what you do for board feet. You got to convert this to board feet, convert. Where was board feet? 8. And it gives you the same number, 807. So you can do it either manually, or you can do it with the calculator. And what else? Is that clear or good?
Yeah.
Okay, perfect. What else? And then the volume. We should show you one more volume one that's been coming up. It's not hard, but let's just go over it real quick so it doesn't. It's almost sometimes when stuff's kind of like easy, you wonder if it's a trick. So let me just erase this over here. Okay. So they might give you a shape like this, and they'll do a circle in it. They'll give you the radius. Let's say this is a 12-inch by 12-inch. This is a column. And let's say the column height is 20 feet. And the diameter is 6 inches. And they want to know how much concrete goes here on the outside. So there's not going to be any concrete in the column, in the cylindrical column. So this is like a steel column. The reason they give you questions like this is because a lot of times in construction, you'll get a set of plans. They'll ask you to use a column here, a steel column here, but the steel column does not meet fire rating. It's not fire rated high enough for that space. So what they'll do is they'll insulate the column with concrete to increase its fire rating from maybe 1 hour to a 2 hour to a 3 hour, whatever is needed for that particular spot, right? And the idea is that it makes it smaller, so you're able to make a smaller unit or smaller column with a higher fire rating. That's why they do estimates like this. So you don't need concrete in this area, you need concrete outside of it, right? So calculate how much concrete that you need for this particular column. You would basically take the column of the big area, which is basically 1 square foot, right? Your face area. And again, we know the column's 20 feet high. We're not worrying about this third dimension yet. We're just going to do the face area and then multiply whatever that number is times the height. At 1 square feet of face area, we got to back out the area of the circle. So if we go back to our calculator, we got 6 inches is the diameter. So it's perfect. And we just go to circle, circle. Now I don't want this in square inches. I want it in square feet. So I'm going to do this. So it's 0.2. I'm just going to round it. So let's go here. So now we're going to back out 0.2 square feet. So that particular column is 0.8 square feet. Now I can multiply that times my 20 feet height. And what's that give me? 18, 16, let's see. 0.8. Oh, let me show you while I'm doing it. So 0.8 feet times 20 feet. That's going to give me 16, cubic feet. I don't want it in cubic feet. I want it in cubic yards. So I'm going to click yards. So I know that this column is essentially 0.6 cubic yards of concrete. So it's 0.6 cubic yards. Now, if I have 10 of these, they might ask you to, let's say you have 10 columns. If I have 10, I just multiply that times 10, and then I know I'm going to have 6 cubic yards for that project. So this is a pretty typical one as well. We go with that one. Oh, sorry. If y'all been chatting, the chat I put down. Okay. No, I think we're good. Okay. Any other questions on that? All right. Let me solve this here. And for the plan reading, I know that module 10, you got module 9 and 10 both have, like a ton of plan questions on there, but you'll probably see, those are much harder than what you're probably going to see on the test. There might be a couple on the test that are tough or difficult. So far, let's see what else on the state test. There was one. How did they go? It was kind of this odd shape, right? It was this shape. So like a pie shape. And they gave you outside dimensions. And then they would do this like X in the middle. And they would give you the dimension from the X to the end of the arc here at 25 feet. And it was a word problem, and it related to cost of landscaping. And the idea was they were going to landscape this shaded area here. So from the X to the arc, they were going to put trees, and maybe the trees were going to cost like $3 or whatever, $3.25 per square foot. And they wanted you to calculate the cost. So in this example, the mistake that a lot of students were making was they were taking 25 as the radius, and they were calculating the area of this between here and here, using the calculator 25, and then, giving the total area and dividing it by 4. And that was giving them a wrong area, because the way you have to do this is you actually have to separate this out into a small circle and then a bigger circle on the outside. And now your first radius for the small circle is actually 15 feet. And your radius for the big circle is actually 40 feet. So using the calculator, you're going to find the area of the 15-foot radius, and you're going to find the area with the 40-foot radius. Just doing the same thing we did on the calculator. You're going to take the difference of those two, and you're going to take that difference, you're going to divide that by 4. So that'll give you the square footage for this shaded area now, the proper square footage for that shaded area. And then you multiply that number times 3, or whatever the number they give you, 325, to get the answer. So I have seen that one as well. But just remember on this one, the radius here is not 25. You got to take the small circle and then the big circle. Once you find the difference, you get the you get the donut shape area, and then you divide it by 4 just to get this shape here. But the plan reading shouldn't be that, it's not going to make or break you, I don't think, plan reading. So, any other questions?
Chris, I got a question for you.
Sure.
Okay, the project management and the project administration, are they both taken on the same day? Do you have to take them on the same day?
No, you schedule those independently of each other through Pearson VUE.
Okay.
You can take them in any order you want. Some students, you could schedule those on the same day if you wanted to. You don't have to, though.
Oh, okay. Because I thought you had to take them on the same day.
No, that was the old days, man. That when I took my test, you had to take business finance on Saturday and the 2 trade test on Sunday.
Oh, okay.
Yeah, but that's all different now.
Thank you.
You're welcome. Anyone else?
Yes, Chris, question.
Sure.
This weekend is the cram on contract administration. And the way we've been looking at is that the way it's been handled is a mixture between contract administration and project management, right? So the third exam. So would you encourage me to take the this weekend cram? I'm preparing for as I told you in July, for the PM.
Mm-hmm.
Would it help? What's your thought about that?
Yeah, I mean, I think it would help. You're basically, though, for project management, you're not going to get that many questions out of Contractor's manual, but you'll get questions out of chapter 10, most likely the project management chapter. And they do review that a little bit in the contract administration workshop. I mean, contract administration workshop, though, is going to focus a lot on Contractor's manual and AIA, and a little bit on the building code chapter 1. And those things you're really not going to see on the PM test. I mean, on the project management test, you really want to focus on modules A and B, which are the the building code modules. So like for PM, make sure, yeah. So for PM, you're gonna focus on 8A and B. That's your Florida building code. You're gonna get probably half the test on Florida building code. 9A and 9B, these are your trade books. Now, of these books, the most important book is going to be OSHA, followed by, I believe, PMP. Now they're asking a ton of general knowledge out of the principles and practices. You'll see a bunch out of the trust, or a fair number out of the trust book. That's the one with the red spiral. And you'll see the UF Energy. That's the one with the black spiral, the University of Florida Energy book. These are going to be what I would bring to the top of your stack. Like when I start looking through that test, I'm going to focus on Florida Building Code building, probably be my first choice. And then I'll hit the OSHA book would be my second choice for looking for questions. And then principles, practices, third, trusts, fourth. Then you're going to get a fair number of energy questions, either coming from this book or it could be the energy conservation code book. And then, you know, obviously you're going to see plan reading, which we kind of went over some of the plan reading stuff that you could probably come across, and just some construction math related to the plan reading. So, but these are your 4 big modules for project management. And then of course the 1B and the 10, those are your plans. So you could hit those again.
Okay, thanks, Chris.
Okay, you're welcome. My pleasure. Thank you. All right, guys. Well, thank you guys. Sorry I had to jump off a little early and I came a little late. So sorry about that. But if you have any questions, just email me, Contractor at Gold Coast Schools. I was out of town for a few days at a conference, so I'm still trying to catch up. So if you emailed me last week, I am going to get to you. I promise. So, but if there's any questions along the way, just shoot me an email, put it at the top of the stack.
Thank you.
All right, guys. Thank you, guys.
Thanks, Chris.
My pleasure. Y'all have a great day.